Hello everyone, welcome back to my channel. So today we'll be discussing the text semantic search with AutoMM collab, and I'll give you some introduction to semantic embeddings. So semantic embedding is one of the main workhorses behind the modern search technology. And instead of directly matching the query to the candidates by term frequency, a semantic search algorithm matches them by first converting the text into a feature vector. So what it basically do is it performs um, natural language processing basically, and it converts into vector space, and this is what is called as vector embedding. Here is one example for this. So first we'll get the data set, and we extract the data set from here, and we load the data set in these variables. We try to visualize the data set, how it looks like. So label data is this is the label data, and this is the query data. We'll be querying this, and so we'll be dropping the URL that are not used in search basically. So we need to remove that, and the doc data have the document IDs as well as the corresponding texts. So now what we'll be doing is we'll be looking at the doc data. So this is how it looks like, and then what we're going to do is NDCG evaluation, which is called as normalized discounted cumulative gain. So in order to understand NDCG metric, we first understand what is cumulative gain and discounted cumulative gain as well, by like taking two assumptions that make when we use DCG. So we use BM25, which is also known as Okapi. BM25 is popular ranking algorithm currently used by OpenSearch for scoring document relevancy to a query. So, so a query is basically a prompt, I would say, and basically a document, and that document is what we're trying to match and try to score basically how relevant it is. So a query, how relevant it is, and based on that, we give the answer. So it is majority of the time used for searches, and so in Elasticsearch also we use the same method, and here we'll define the functions that we'll be using. We'll be tokenizing the corpus. So tokenizing basically means extracting the token words, trying to eliminate the words from the document that is like articles or. And one more function we're going to make is a rank document BM25. So once we are done with loading the data, now we'll be initializing the predictor. So we will be using multimodal predictor, and we'll hyperparameterize it and give the label as label column, the data that we have. And also we need to specify query response with the corresponding label data frame. So yeah, we did that, and now we'll be evaluating the ranking, and evaluating the ranking is easy with evaluate function, evaluate API actually. So we'll be using that. And during the evaluation, the predictor automatically extracts the embeddings and compute the cosine similarities and rank the results and compute the score basically. So it will provide us with the rankings. Here they are for different types of model. And now we'll do the semantic search. We also provide a util function for semantic search that is called as semantic underscore search, and we'll be using that, and we'll try to extract the embedding by using the dot extract embedding function. And now we'll define functions for the hybrid BM25. So the summary here is that we have demonstrated how to use AutoMM for semantic search and showcase the obvious improvements over the classical BM25 by using hybrid BM25. Let's move on to the next one. Here we're gonna do entity extraction with text and image, and we have introduced how to train an entity extraction model with text data. So here we move a step further by integrating data and other modalities like image. So we'll be doing that. And to begin with, we obviously loaded the data, and then uh, gave it a path expander, and then we're training. So now let's fit the predictor with the training data. And firstly, we need to specify the problem type to NER, and as our annotations are used for text columns to ensure the model to locate the correct text columns for entity extraction, we need to set the corresponding column type to text NER and use the column types parameter in cases where multiple text columns are present. So here we do this quick demo, and then we evaluate using dot evaluate function, and then we try to predict using dot predict function, basically test the test data. And here we are reloading, and continuous training is done. So let's move on to the next one. This is the forecasting in depth, and for that specifically in this collab, we will cover what is probabilistic time series forecasting, forecasting time series with additional information, and what data format is expected by time series predictor and stuff like that. So let's move on and see. So here we have downloaded all the necessary dependencies we need, and we load the data using the pandas, and this is how it looks like. It has a timestamp and target to it with the item ID. And this is another data that is a static DF data, which does not have a timestamp attached to it, but has a domain with it. And Autogluon basically expects static feature as a pandas. So data frame object. So the item ID column indicates which item is equal to like the image individual time series. In DF, each row of static features corresponds to that. So we can now create a time series data frame that contain both the time series value and static features. So here we are trying to create that using the time series data frame. And once we are done, we'll try to train our data. And for that, we're using static features. So finally, to make predictions, we generate the known covariates for forecast horizons. And for that, we use pandas data frame. And once we are done with that, we'll install holidays. So which is another popular example of known variates are like holiday features. So in this section, we will describe how to add holiday features to a time series data and use them in Autogluon. And for that, first we need to define a dictionary with dates in date time dot date, and format as keys and holiday names as values. So that is what we're doing here. So we'll be handling irregular data and missing values as well. This is the part of data cleaning process, and so this is the code for that. So once we're done, our trained data looks like something like this, and the test data looks something like this. And then we'll use time series predictor to predict, and dot fit function to fit the training data over it, and we'll start our model. And so this was the original time series, and the validation splits. Uh, and once we are done that with that, we'll use this predictor dot fit function, and we'll fit the training data and tune data by and the tuning data as my validation data set, which we earlier downloaded. In this collab, will be forecasting with Chronos Autogluon time series, which is also called as AGTS. Now features Chronos, a family of pre-trained time series forecasting models, and Chronos models are based on language model architectures and work by quantizing time series into buckets, which are treated as tokens, and language models are then trained on these token sequences using cross entropy loss. So we'll be downloading the dependencies, and once we are done with that, we'll start Chronos, and we'll load the data, the time series data. It looks something like this, which has timestamp and target and item ID as well. And now we'll straight away predict using the time series predictor model. So now we'll use time series predictor to predict to make our predictor model and fit and set the presets as Chronos underscore tiny, which is a low level of preset, I would say. And once we're done with that, we'll predict the train data, and we'll store it in the predictions, and then we'll plot it. So it looks something like this. And so model not specified in predict. So it will default to the model with the best validation score. So it shows chronotiny in this one, chronos tiny. So now what we're doing here is we are making another model using time series predictor and hyperparameterizing that model. In this collab, what we'll be doing is we'll be making a deep learning model zoo of model zoos, and it can automatically build deep learning model that are suitable for multimodal data sets. You'll only need to convert the data into multimodal data frames format, and AutoML can predict the value of one column conditions on the features from the other columns, including image, text, and tabular data. And to begin with, we'll be loading the data. We'll be using the pet finder dataset, and for that, we're using pandas to basically import the CSV files that we have in the zip file. And after that, we'll be using the path expander so that we can expand the image paths to load them in training. And once we're done with that, we'll see how the data looks like. We'll try to get the description of it. So it says something like that. And this is the image of the pet. And now we'll be training the data. So we'll be using multimodal predictor, and for that we have the fit function to fit it, and we have set the time limit to 120 seconds. And once we're done with that, it will give us it will prepare the model, and we'll be using predictor.evaluate. So it is giving us 60%. Using the test data, it is showing us that the model has 60%. So now it's time for evaluation. So we can use predictor.evaluate and use the test data, and it is showing a 60% of accuracy. Once the prediction is done, given a multimodal data frame without the label column, we can predict the labels. So we'll drop the label columns and again predict. So uh, we'll drop the table column for this test data and predict again. Try to use the same. And since we are satisfied with our prediction accuracy, we'll try to extract the embeddings and save the data, save the model. So it is giving us 60% accuracy, which is pretty great for this complex problem. I hope you learned something out of this video, and thanks for watching the video. And if you like the video, please hit the like button and subscribe to my channel.